Well, hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, we're going to be taking a look at these 3 random NES or Nintendo Entertainment System motherboards. These were all given to me in unknown condition the other day, and I just wanted to see if, well, these things work. And if you're familiar with NES motherboards, you can tell that this one's not going to work because it's kind of missing a piece, a critical piece. To facilitate the testing of these, I have a parts NES machine right here. This thing, as far as I'm aware, it does work. It is missing its cartridge mechanism, loading mechanism thing that's in there, but it does have the cartridge connector in the back. So you can actually, well, with the lid off, you can get a cartridge into there, and this thing does actually work. And for a parts machine, you can see this thing has, well, a really good condition case, actually. Not yellowed at all. But anyways, all I really need out of this are the joystick ports here, because I don't have any of them free for these. Along with, of course, we have to hook up the power switch and reset switch. Although, with the motherboards, I was given 2 of those little boards, which are those right there. And then, obviously, we'll plug a controller into it. That was separate. I already had that. And then I have to plug that cartridge adapter into it. Now, in case you're not familiar, the reason why you need the cartridge adapter is because on the Nintendo Entertainment System, the motherboard sits in the console this way, upside down, and this edge connector right here, if we zoom in a little bit, this edge connector, which is not gold-plated, I might add, is what connects to the cartridge loading mechanism. So there's like a bracket that goes on here. Well, it's sort of a cartridge connector, and it loops around like that. And then when you put the cartridge into your console, it slides in like this. You push it down. That latch mechanism is connecting it to this through that angled bracket, which we'll look at in a second. So when we look at an NES motherboard, there are a few critical components. We have the RP2A03G, that is the CPU. So it's like a 6502, but it also has the sound generator built in. So all the NES's sound, yes, it comes out of the CPU chip itself. We have the RP2C02G, which, if you take a look right here on the motherboard, U5 PPU or Picture Processing Unit. So that's the graphics processor or graphics chip on the NES. There's a 74LS373, that's a latch. This chip right here, if I recall, is the Lockout chip, the CIC. So that's what interfaces to the similar chip that's inside the cartridge. And if you try to put a clone cartridge into your console, it's not going to work. And this thing is also responsible for that flashing you can get when a cartridge is in the slot and it's a legit cartridge, and yet the system will not stay running. It keeps rebooting over and over again. That is this particular chip. There is a very simple bypass you can do. I think you just cut one of the pins on this thing, and then it is out of circuit altogether, and then you can use any kind of cartridge you want without any issues. These 2 ICs right here are some static RAM. One of them is for the CPU, it's like work RAM, and the other one is for the PPU, it's the OAM, object something memory. It does say VRAM right there, and WRAM for work RAM. Obviously we have an NTSC system here, another TTL logic IC, another one over here, and we have a couple 40 series logic chips up there. And that's actually pretty much it when it comes to components on the NES motherboard. It's very simple. This connector right here sticks through the bottom of the NES case. If we grab this, it would be exposed if we pop this little cover off here. Nintendo was thinking eventually they would expand the US market NES with additional peripherals like a disk system like they did in Japan, and that could connect to this bottom connector. Since the cartridge connector had that, whole mechanism for slot loading and it wasn't top mounted, you couldn't have the disk system like on the Japanese version, where instead of it being something that connected to the bottom of the console, and you obviously really wouldn't work if it was something that had to stick inside that slot all the time, they were going to use this bottom connector to do the same thing. From my understanding, it pretty much has the same signals as this connector, but I haven't actually looked that up, so I'm not 100% sure. The blue connector right here is where the power and reset switch connects to. So this simply passes the power out and back into the machine, and the reset, well, button as well comes through this, and then the power LED. These 2 connections right here are for the 2 controller ports, and on the North American NES, there are only 2. The Japanese family computer has 2 hardwired controllers that use the equivalent of these 2 ports, but then there's an extra connector on the side, which is good for expansion type controllers that would plug in externally, like the keyboard, but also additional types of things like light guns and stuff like that. Next up on this, of course, is this little box right here, which is the RF modulator, and it also contains the voltage regulator for the system. Let's just get a closer look at that. So the NES takes 9 volts AC input, it's rectified to DC, and then it is regulated down to 5 volts with this. And this is the heatsink, which also is connected to this stuff here, so some of the heat is passed through into this entire box. But generally what this does is it takes the video signal, which is composite, that's what comes out of the PPU on this thing, and it outputs the composite video plus audio and then an RF signal as well. And we have a channel selector switch plus the 9 volts AC input. So without this on the board, things are not going to work. Now, for whatever reason on this one, someone decided to, I guess, just snap off that entire system. This was not taken off gracefully. It was almost like someone just grabbed the whole RF modulator here and just snapped it right off. So there's no way that this motherboard is going to work, but that doesn't mean it's junk because we have the custom ICs on here, which are absolutely necessary for the operation of NES consoles. And if I was ever trying to convert another console from a different region into NTSC, you would need both of these ICs. As far as I'm aware, the Japanese market consoles plus the North American ones use the same chips. The thing about 8-bit consoles like this is that they're very timing dependent, and the video signal is generated by the clock signal that goes into the CPU and it's divided down. And therefore, consoles in 50 Hertz markets that are PAL, for instance, the games play at a different speed and the music is even at a different frequency because everything on the NES is derived from the master clock. So in order for this to work at 50 Hertz, you have to have a different master clock, which changes everything else, including the speed of the CPU and, like I said, sound and all that kind of stuff. Now looking at this one here, it looks like someone brutally ripped off the cables that were on here as well. These were the connectors that went to the game controller ports and they just, and look at that, they got bent up. So that kind of sucks. But like I said, these are the two useful parts on here. Oh, and I just noticed that the SRAM chips have a smaller footprint than on this one. Does this actually have both? Yes, it looks like the PCB, at least this revision of the PCB, can accept either footprint of the SRAM. There's nothing really special about the SRAM here. I think there are plenty of SRAM chips you can use in place of these. And then the final motherboard is this one, and this one also looks like it got yanked a little bit, although it's probably nothing damaged. For whatever reason, this one is missing the heatsink. I don't understand why. Was someone stealing that for another console? Is this thing broken? Maybe. Everything else on this particular board looks just fine. And honestly, it's, well, these things weren't stored appropriately. They were just in a box full of random junk. But I have a feeling that probably all three of these work. Well, obviously, this one's not going to work with the missing modulator and power supply there. But I bet you these chips work just fine. And I think what we'll do for testing on this is desolder the chips, at least the main chips on here. And I'll socket them on one of these boards if it works, of course. And then we can test everything out. Okay, so first step is let's just break into this console here. And I want to get out that cartridge connector thing, plus the controller ports, because we're going to need that to do a little bit of testing. It's my recollection that there are only 2 screws, yep, in here, and that's indeed the case. Okay, well, there's inside an NES. Now, normally if you open one of these up, there's going to be a bunch of RF shielding, and then there's going to be the loader mechanism for the cartridge connector, as I mentioned. So this goes in there like that, and then the mechanism holds this down. Now, for testing purposes, it is possible just to kind of hold this in the right position, and then the console should work. In fact, before we do anything, let's just test to make sure that this console is working so that I have all the cables correct. A funny little side note is for the power supply on these NESs, I always seem to just use these Atari 800 power supplies. I always have these things floating around, the Atari 400 and 800 plus the 810 disk drives. They use 9 volts AC. It's a nice stout power supply. This is obviously not an original one, it's a replacement one, but it works perfectly for NESs because, as I said, 9 volts AC rectified to DC. You could certainly plug in 9 volts DC into this, any polarity, and that should work as well. That is one of the benefits of having a bridge rectifier inside the power supply. You can feed it DC and it works. All right, I'm going to use this multi-cart here for testing. Just need to put this down. I'll just stick this remote control on there. Maybe that'll do the trick. Oh, this one does not have the mod done to it because it's flashing. The Lockout chip is flashing on it. So we're going to need to do that mod. Part of me wonders, actually, is have I even tested this board? I may not have. I don't know where this then came from. I think this was also a scrap board that someone gave to me. Okay, so for the CIC chip, I moved these components out of the way. The pin we're interested in is pin 4, which is this one right here. that thick trace. I think this goes to 5 volts, and we're going to be cutting that. I'm just going to use some cutters like this, and you just want to make sure you cut just that pin like that. And now that chip will have no control over the reset line on the NES. So therefore, if the cartridge like this one has bad contact or doesn't even have the CIC chip in there, I think this does have a working emulation of it, then the console will not keep rebooting like it was doing just now when I had it turned on. All right, let's give this thing a try again. So I'll just pop this down, we'll plug in the power, and let's see what happens now. There it is, freaking works. Be aware that it's not just that lockout chip that causes issues with the motherboard, but if you're using cloned cartridges or ones you've like put your own ROMs onto and stuff, then you're gonna need to defeat that CIC chip. But back in the day when I had an actual NES that I played a lot when I was young, I did have a lot of trouble just with that specific CIC chip, because it's like the signals are carried over one of the pins or whatever on the cartridge connector. So you could have all the other pins connected properly. You can kind of tell because some games, when you boot them up, you'll get the boot screen and music immediately, like say Super Mario Bros. 2. And then what happens is the CIC goes, oh, I can't talk to the cartridge or the CIC chip in the cartridge. And then it does that constant resetting of the machine. So it's like I'm pushing the reset button like this every second or so. That's like a simulation of what it does. But you can see that this cartridge is working, and just having the remote on here is enough weight. If I take that off, you'll see that the machine's not working. And the remote is all it really takes. So here's Super Mario Bros. 2. There it is. And I think everything should be working fine here. I don't know if this music is copyrighted, so we'll turn the audio down. Not to mention, if I make any cuts, you'll hear it from the music playing in unsynchronized or incongruous, or I don't know, I'm making up terms there. I don't know what I'm talking about. So yes, I'm playing through the scaler, not to mention I'm playing through OBS, so don't judge my playing here. It's very difficult because of all the lag. Whoops, that's not what I meant to do. Obviously I can't use this anymore. No, anyways, look at this. Terrible, terrible. Yeah, the extra mushroom is over in the other area. But anyways, the point being is that this particular console is working now. So now it's time to test those other motherboards. Okay, so because all the screws are already removed from this, this just slides off like that. So this is the, you know, thing that goes bad on all of these consoles. But I got to tell you, this is my original one here that was, well, in this case, and I've had this case forever. I think a friend gave it to me for whatever reason, like maybe it was the early 90s. Anyways, this is the original NES part. This is not a clone. And did you notice how it worked perfectly? Well, you know why it worked perfectly? Because, I'm just reaching over here, you add some Deoxit and it freaking always works. You got to make sure that these pins here are in good shape since they're not gold coated or anything. But you clean those up with a little magic eraser, a little Deoxit, put some Deoxit in this, and then it always works. And I have several NESs now. I have this parts machine, but I have, I think, 3 more upstairs, all with their original connector, and they work 100% of the time. I never have any cartridge issues whatsoever. I mean, it can be years between playing on that thing. Pop a cartridge in and it just works. I'm talking about my original cartridges too, like from the old days, not these modern reproductions. And it was Deoxit. Deoxit always fixes them right up. In fact, the reason why I have multiple is because people have given me these consoles saying that they're broken, and I haven't even made a video about it because there wasn't really much to say, because I just sort of open it up, put some Deoxit in there, put it back together, and it just freaking works every time. These NESs are so unbelievably reliable. So yeah, speaking of that, let's go on to try these other ones. Okay, so this is the first one, and I can see that there is a little bit of oxidation on here. So what I'm going to do is grab some magic eraser, and we'll put some Deoxit on there. And then we'll use the edge of the magic eraser here and just kind of polish that up a bit. And you see all that black stuff there that came off, that's the oxidation. Same on this side. Ideally, actually, you should use some scissors. Cut yourself just a small little piece of this. You don't need much, just a little bit of it. Allows you to kind of get that oxidation off. Yeah, I mean, look at that. That all came off there, not ideal. So I think this is one of the issues with these consoles, is this connector gets oxidized. I don't know why they were stingy and they didn't use ENG coating on there, but they didn't. So this is the one that does not have the missing heatsink. Okay, we just get this on. Oh, you know what? I didn't do the CIC lockout defeat. We got to do that because I don't think this cartridge is necessarily going to work. So again, we just move this stuff out of the way here. All right, remember pin 4, which is this one right here, like so. We'll just pop the cartridge thingy back on here, like that. This stuff reminds me of these cables here. So I had an NES that never worked properly with the light gun. It just did not work. And I assumed it was my light gun that was bad, and I actually went through 2 because I only had one NES and it did not work. So I went through 2 light guns and I'm like, what's happening here? And then I started looking into what, how they worked and everything. And I finally opened up the console. Well, it turned out what had happened is the joystick port 2, when it was assembled at the factory, because I could tell this was originally like this, one of the wires was sort of stuck on this standoff right here. I don't remember which one it was, but it was like this with that blue wire on there. And then when they put the screws together, it actually broke through the wire. So that's why the light gun never worked. If I recall, the controller worked though, but just not the trigger on the light gun, I think. I can't remember. I think it's a separate signal that maybe is for the light gun than the controller. So yeah, it was just funny. And it was all because a wire was broken and pinched. And all I had to do when I opened it and I saw that, I just had to solder it together. And then, well, that fixed that problem. That's one of my NESs upstairs that has that issue. And it, like I said, it always had that issue all the way going back to when it was new. So kind of shoddy quality control there on Nintendo's part. So we turn this on. We're not getting the flashing because the CIC chip is disabled, but the console turned on there, so that's a good sign. Let's just pop this on, and we'll put the old joystick. We'll put the remote control on there for a little wait. We'll plug in the controller, power this on. There we go. The sound wasn't working because I had the volume down. Super Mario 2 again. Yep, it freaking works. Of course it does. Let's see here. Yeah, no issues. So, of course, stored in a box of random junk, and it just freaking works. Freaking works perfectly, of course. It's amazing how reliable and how hardy this stuff actually is, isn't it? Well, let's get the... Oh, go away. I think what are those called? Shy Guys? Anyhow, so yeah, this is working great. There's nothing surprising about this to me. This old electronics is just so reliable. It's pretty amazing, really. Oh boy. It's tough to play when you're doing it through so much lag. There's far more lag because of OBS than even on like a flat screen TV. And plasmas and LCDs, they introduce a whole bunch of lag, but there's a ton more lag here. Whoops. Yeah, I'm really not doing well here. I'm going to say that this console is working great as well. So I need to grab a marker here and start marking these up. All right, well, the one here that was in this case originally has a check mark on it already, so I don't need to do that one. But this one here gets the tick mark. Oh, that's not very easy to see. I shouldn't use a silver Sharpie, should I? Let's use something a bit more visible, like the black here. Tick. All right, so 1 out of 3 working well. All right, so for the next one with the missing heatsink, I'm gonna go try to find something to stick in there. What can I put in there that would work? How about this slot cover? Will this work? Can I slide this in where the screw hole lines up? Oh yeah, I think that's gonna work. All right, well, that's not ideal, but that's certainly gonna work. I don't think that's gonna cause any issues. A lot of the heat, like I said, goes into this shield as well, now that that's pushed up against there, but this little thing will add some extra heat dissipation, and it doesn't block these as well, so that should work. If it fits in the case, of course. Let's just see real quick. I think it will fit, I think. Yep, fits just fine. It might interfere with some of the top cover, but honestly, I could just cut this down or, you know, find something that's more appropriate. I just wanted to see if something worked, and I think this is going to do the trick, at least for testing purposes. All right, so let's just do the old CIC defeat on here once again. So pin 4, snip. Amazing how easy that is. It just takes a second. Funny that back in the day, that was not something that anyone ever thought to try. But the entire CIC circuit just was not well understood back in the old days, at least not conventionally. Like people didn't, well, there wasn't a lot of knowledge floating around on the internet. And it's not like Nintendo Power Magazine was going to publish information on how to defeat the CIC circuit, right? Oh, and I forgot to put the Deoxit on the connector here. So we'll do that real quick. It's definitely got a little bit of oxidation on there. Amazing how much comes off of that. All right, let's see if this powers up. We're getting a power LED, so that's a good sign. Any heat coming off this regulator? Nope, it's nice and cool. I forgot to put the cartridge edge connector on here. There we go, put that there. All right, here we go. Is this thing gonna work? Of course it's gonna work. It's a it's a Nintendo. Ultra freaking reliable. Look at this. It's just amazing, absolutely amazing. Why don't we try a different game, see if this works? I think Shatterhand, a little bit more of a modern game than Super Mario Bros. 2, so pushes the console a little bit. Let's see here. So obviously that is working, so I'm gonna say that this console works as well. It's just weird. Why would someone steal just that little heatsink off the modulator there? With the console having been on for a little bit, there is actually a little bit of heat in that. The shield on the modulator itself is cool, but this thing here does have some heat, especially over there on that end. It's cool over here still. So cool. I think that's probably relatively effective. You don't need a ton of cooling for the 7805s if you're not pushing a whole bunch of voltage into them. So we're getting a check mark on there as well. And now we have to see about running this board. Now we lost some extra components right here. See, like that choke and these things, those are gone. But I wonder if we just feed 5 volts into this thing and we clip onto the video output from the PPU, which is composite, if we'll actually have a working system without the need for that entire part of the PCB. It is possible. And it looks like we obviously have ground on the outside, so we don't need to worry about that. But from a 5 volt perspective, let's just go on this TTL chip here. It's gonna be one of these pins here. Seems to be the middle pin. We're getting less than an ohm there. So if we take the power supply leads here, we clip onto here for ground. And we clip into the middle pin here for 5 volts. And we very quickly cut the pin on the CIC chip here. Whoops, these cutters have a broken tip on them. Not ideal. There we go. And we need to find the video signal for this. So we're gonna use the Zoe here. I have it set for 1 volt per division. On the bench power supply, you can't see, but it's connected to these leads. I have it set for 5 volts. Let's turn it on. 280 milliamps or so is what we're getting on here. All right, so let's probe around over here and let's see. Oh, there's our video signal right there. And we have quite a bit of an offset there, so we're gonna need to use a capacitor. I don't know what's going on with this thing. I don't understand why it's... Is that like microphonic? I don't know what's happening with this. It's this multimeter. I don't know if it's the probe or what's the deal there. Anyways, if we go to triggering and we move this down a little bit, we're seeing a good video signal. It's nice and solid there. So the reason why this goes down sometimes is it's gray up there, but occasionally, probably in the vertical blanking, it's actually at black level. So when black level happens, it's down there. Color burst, sync, it all looks perfect. Now, if we take the power switch here and we push power, that doesn't do anything but reset. Yep, reset makes the sync signal and the color burst go away. That's obviously normal for the way this thing works. So this looks like a working system. So on one of these other traces, probably going to be the audio signal. The only way we're going to know that for sure is to try to get a game working on this thing. So let's cut the power to it. Now with this particular NES here, which does appear at least to be working for the most part, this would be a good candidate for one of those modern recreations, the ones that are replacement PCBs, because clearly this PCB is not going to work ever again, not properly at least. Okay, so the oscilloscope is clipped onto that resistor, which happens to be the same video pin that I was on before. It's on ground there. We got 5 volts, ground there. Let's flip that over so we can get the cartridge installed here. Oh, I'm going to need a way to hook up a controller, obviously. Put this there, just like we've been doing. What we're looking for on here is video signal beyond just the solid gray, which is what we were getting before. I think we're good to go. Let's just connect the ground better there. And here we go. Okay, we're not getting that signal I expect. Let's take the cartridge out there. What's happening here? Well, interestingly, we seem to have lost operation of this particular console. We're just getting a solid gray screen now. It's actually acting as if we were holding down the reset button. What happened here? What happened? Oh, look at this. Look at this oscilloscope. It's super unreliable. Oh, I don't know what's going on here with this. Come on, come back to life. There we go. Yeah. Okay, I don't, Well, interesting is the only thing that really changed, I'm turning the power off and on, is this being on here. Does it seem like we get a little pulse of something on the video signal there as the power goes away? I'm at 5.06 volts. If we turn down the voltage, I'm at 2.8 something now. There we go. Okay, I'm at 2.8 volts, and we're obviously getting some kind of a video signal there. Turning it up now, we're at 5.1. How weird, I don't understand. I just turned the voltage down and back up again without actually doing anything else. Oh, and look, we have a power LED. Wonder if I had a bad connection then. Okay, reset is acting as I would expect. I'm actually really not sure what was causing that particular issue. Well, let's get this cartridge connected back up. Turn the power off there. I'm actually just going to lie this right down on top with the motherboard sort of sitting on there. And is it doing that thing again? Yeah. Let's put something on here as a weight. What's happening? It's doing that again. I don't get it. And the light's not on either. Okay, what if I hold down reset while I power it on? It's like it's... Okay, wait a second here. Let's check for voltage drop here, because this screams that this thing is not getting the right voltage here. We certainly are getting the right voltage. And on this IC, we're getting 5.1 volts. Of course, nothing on the ground pin. Let's do that thing again where I turn the voltage all the way down. Okay, it's down around 0 volts now. Now I'm turning it back up slowly. And we are at 5 point whatever now. And let's hit the reset button. There it is. It's running. I'm just curious about the turn-on behavior. Is this something due to... Oh, it died. It was running, and look, the light's gone. So if I turn down the voltage again, let's turn down the voltage all the way down to 0. Check the LED right here by my finger. There it is. 5.1 volts. We push reset. There's the game running, and then it cuts out. What? I must have this hooked up in the wrong spot. I don't know. On the power supply, we're only drawing 281 milliamps. If I turn the voltage all the way down to 0 again, like I did before, and we turn it back up when this thing is running. Oh wow, it did not start back up that time. I don't know, I'm obviously doing something wrong here. Like maybe there's a voltage check circuit or something that's unhappy. Let's get that out of there. Let's see what happens if we turn this thing on. Okay, so it's doing this again. The funny thing is, when this goes into this weird shutdown state, there is no additional current draw on the power supply. We're still at about 200 something milliamps, and that's it. The system obviously is showing some garbage right now. You know, it was almost approaching 5 volts there, and the current draw never changes. It just goes to this, and then the power LED shuts off as well. That's what's a bit curious. But obviously when we hit the reset button, notice how the power LED shuts off, so it's connected to that circuit. But here at like 4 volts, system, oh, well there it is, it cut out. Okay, so I've been investigating the reset circuit on this NES. I think the problem is in the CIC chip actually. It looks like it is what generates the reset output. So reset here, this goes to various ICs on the board. It gets buffered and sent through this 220 ohm resistor to an LED, and there's the reset switch right there, which is pulled up to 5 volts. And from the best of my understanding here, since this is a buffer that is an output heading down to the bottom here, looks like the pin 7 on the CIC chip is actually able to sense whether you hit the reset switch, and it pulls it up to 5 volts through the LED. My assumption is when the system is out of reset, pin 9 here goes high, and I can definitely confirm that pin 9 on this chip is always low, unless I do that trick with the power supply, then it goes high. So I think what happens is when this thing is high, that means the system is operating, and then what happens is this inverts it down to ground, which the LED sees, and there must be 5 volts on pin 7 here, I guess, all the time. And when you hit the reset switch, this is definitely connected to 5 volts. So that is the symbol for ground, but that is the symbol for 5 volts. And I guess the chip can sense there's no current draw for the LED here when you're pushing the reset button, and that resets the system. It's kind of unusual. And obviously when you reset the system, then what you're getting here on the output on there is a reset signal that goes to all the chips. Pin 4, which is the one I cut, I did test by reconnecting pin 4, but that didn't change anything at all. So this is not unlike the Plexus P20 reset circuit that went bad. So I think I just need to bypass this entirely as a way to test. I think what I'm going to do is just try a different set of switches here than the one I was trying. Maybe it is sensitive to the switches that you have installed, and they were causing this particular issue. I'm not 100% sure. All right, so the system is currently powered up right now, and obviously nothing. Now I do notice if you look at the power LED, when I press the button on the power supply to turn it off, that will blink. Well, I could see that earlier. When you get the little glitch on here when I turn it off, see that? Well, sometimes you get a little glitch where it goes up. It's not doing it now. Let's do it the manual way here. Turn this down. Oh, see there? The light came on for a second. Turn this back up. There's the light coming on. We're at, just watching, I don't want to over voltage this. There, it turned off. So yeah, I think there's something going on with the CIC chip that's on this board. And I mean, unless there's a component missing, I don't think there's a component missing though. Let's just double check real quick. Yeah, nothing is missing from this board. The only thing that's missing over here is this stuff. And I looked on the schematic, and this is for the audio circuit, this little capacitor right there that's been ripped off this board. So that chip must be bad. I don't know what else to say. So I'm just gonna remove it from the board entirely, and we're gonna see if I can just hotwire the reset circuit altogether. Alrighty, so what I've done is I removed the CIC chip. Let's zoom in a little bit. So I removed the CIC chip, and I went from pin 9 with a resistor to 5 volts. And as you can see with the system powered up, we're getting something on the screen there, that is. Now, just like on the Plexus, the only way to reset this machine is to clip onto that resistor lead and then ground the the input there. So if we do that, there it is, we're in reset, and we take it off and now we're out of reset. So there we go, manual control of the reset circuit. It's not ideal. There should be a debounce circuit and stuff like that in there, but I think this is good enough just to see if we can get this thing running again. So we power off the console. Let's get the cartridge connector back on here. There we go. Let's just get this with a little bit of weight on it, like so. And this is the video signal, so when we power this on, I don't expect it to work, so I'm just gonna hold the system in reset here. When we power it on, take it out of reset. Well, we saw the thing was running before. We're getting 292 milliamps, 5.06 volts. Put it in reset, take it out of reset. Huh, interesting. The cartridge wasn't on all the way. I think that was the problem. Put the console in reset, turn it on, take it out of reset. There it is. It's freaking working. So that's the menu we're seeing there. Just want to carefully let go of this. Yes, so definitely was that CIC chip that was bad on this board. And there it is. We actually have a working console. As you can see, here's the leftover bits of the CIC chip. Yeah, I just sort of cut it off the board since it was already bad. I was sure of that. We took it off, not to mention, of course, you don't really need that chip. I could easily replace that reset circuit with a little 555 timer circuit and wire it into the reset switch if we wanted to use this board again. But as I mentioned, this board will never be used again. This is clearly a spare parts board. Now looking at this video output here, we have a DC offset in here. So I should hook up a capacitor in line with this to get rid of that offset. Okay, so we have an inline capacitor on there. Let's put this down. Let's power this back up again. Make sure everything is actually pushed in. It is. Ground is on there. Okay, here we go. Power this up. Pull the reset off. There it is. System is running. Okay, and looking at the video signal, it's definitely a bit too hot. We have a max of 1.4 volts. So obviously what the RF modulator does is it has some circuitry, has like a buffer and stuff like that, and it fixes this to make it proper NTSC 1 volt peak to peak. It's a little bit hot. I think if I plug it into the RetroTink, we might actually get an image. We can watch this as I clip this on. There might be too much load. It might pull this way down. We'll see what happens here. Oh boy, yeah, okay. It cannot drive the video signal. Whoop, it just ran out of disk space. All right, so to do that again, the PPU cannot drive a video signal to 75 ohm load. So if I connect this thing up here to the RetroTink, you will see what happens. It kills the video signal output. Yeah, it needs to have a buffer, transistor buffer driver, which is actually in the RF modulator. It's very much like the Commodore 64. The VIC-2 needs some buffers in order to drive this. So replacement RF modulator or whatever would work. But this is telling us right here that the system is absolutely working. In fact, I suppose what we can do is I can take out one of these for the controller, and then we can actually try to boot a game. We can't actually see what we're doing, so we're going to be operating blindly, but we should be able to see that the video signal changes. Pins are bent up in here, so I cannot easily connect the controller port. Okay, there we go. After some bending, let's try to get this working again. The whole thing is so janky. How many things can I connect up to one poor broken motherboard? Okay, power it on. Pull the reset line off. There we go. System is running. Now if I hit play on there we go. We're in a game. I think there's some animation happening on the screen. You know, I should shrink this down a little bit. And we'll move the trigger point down here into the sync pulse. So if we hit start, I don't know, stuff is happening. It's working. It is definitely working. Let's reset this to console again. Boop, reset. Let's hit start on whatever the top game is there. Okay, what's happening is this capacitor is causing it to float up and down. All right, I think I've proven beyond a shadow of a doubt that this motherboard is working as well. We didn't see actual video on a monitor, and obviously we didn't test to see the sound is working, but the CPU is obviously running the game, and we are getting a correct color NTSC video signal out of this thing. So I'm gonna say that it is absolutely working. The one thing that went bad, I'm just looking for the part here, is the CIC chip, which seemed to have been working originally, and then it kind of failed where it was keeping this thing in reset all the time. maybe cutting that pin 4 is not a good way to go and you can cause issues. Although I have to say, I cut that pin on these 3 motherboards, but I've cut it on all the NESs I have upstairs too. So I guess I've done like 6 or 7 machines that way now without any issues. So if you've run into problems with the CIC malfunctioning after you cut that pin 4, I'd love to know about it. Maybe that's this like particular revision of motherboard, it's more sensitive, or is this something to do with the fact that, well, this has this big missing chunk here and there's some corrosion on the back. Oh, incidentally, I did add an extra 5-volt line from that middle pin over here because I looked at one of these other boards that wasn't damaged, and a lot of the 5-volt traces and stuff go through under the modulator there, and that's missing on this board. So I thought initially the problem with the CIC might be problems with the 5-volt rail not being solid enough. Maybe it was passing through a tiny trace or a component and that was causing the issue, but putting that on there, it didn't make any difference whatsoever. That CIC chip had just failed on this board, or was already failed. So as I kind of suspected, NES motherboards seem to be ultra reliable. These 3 that I worked on today, all were just in a box of junk. They were just thrown in there with a bunch of other stuff. There was no anti-static bags, there was nothing. They were just banging around in there. I noticed a few little scratches here and there on these. My assumption is these were from NES consoles that were slated to die. Maybe they were all not working because someone tested them, and due to the lack of Deoxit, well, you didn't have a good cartridge connection and they wouldn't run any games, so they were all condemned. And the rest of the consoles gone. I don't have anything except for these power switch modules, 2 of those, but that was it. The rest of that stuff is gone, but these all actually work. Even though this one was brutalized, it does still work. So the question is now, does anyone have any thoughts and ideas of what I should maybe do with these? Obviously, these spares I'm glad to have because I want to always have a working NES. It was really a console that I had when I was a kid, and I absolutely love the NES. So it's one I would always like to have real hardware with, and even though I have a bunch of machines now, which were all assembled from scrap parts like these, it's nice to know that in case I need an extra CPU or video chip or whatever, I have them. But as for this motherboard here that's never going to clearly work in a console again, maybe there's something fun to do with it. Can these parts be used for something fun and interesting? If so, definitely let me know in the comment section. And let me know if you thought this video was interesting. Thumbs up, thumbs down, you know, all the usual YouTube junk. And huge thanks to my patrons. Names are going on the side of the screen over here. They make it possible to do this full time. So thank you very much to them. And I guess that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.